Welcome back everyone. We are discussing module 4 engineering geology. This is session 6. Today we are going to discuss natural hazards. So floods, cyclones, tsunamis, these are all natural hazards. Under this today's session we are going to discuss the causes, the impact and management of some natural hazards. Okay. Let's see one by one. So natural hazards are the naturally occurring physical phenomenon caused either by rapid or slow onset of events which can be geophysical like earthquake, landslides, tsunamis or volcanic activity, or it may be hydrological like flood and avalanche, and it is climatological like extreme temperatures, drought conditions, wildfires, etc. Or it may be meteorological reasons like cyclones, storms, wave surges, etc. And some natural hazards are due to biological reasons also, like epidemic diseases, pandemic diseases like corona, etc. Today in these natural hazards we are discussing about the floods. So floods are the most common type of geological hazards, and they are predictable. Why they are predictable? How they are predictable? Because they are seasonal. Okay. A flood is a common overflow of water that submerges land which is usually dry, in which the water breaks the levees or that natural bound, okay, and escapes from its usual boundary. Floods affect more than 65 million people every day, and we are observing that from three consecutive years, 2018, 2019 and 2020, southern parts of India, okay, especially Karnataka and Kerala, highly affected by floods. And more than 80% of Indian territory is affected by, or they are prone to floods. So in Southeast Asia during monsoon season, the rivers swell more than 20 times than in their dry season. Okay, so about 30% of all large dams of the world are mainly designed, or they are flood management systems. Let us see the causes of flood. Okay, so these are the some of the snapshots from Karnataka Kodagu. Okay, of 2020 flood. We can divide the causes of flooding into two major headings. One is physical causes, that is natural causes. Other one is human, that is anthropogenic, man-made or man-induced, human-induced. So in physical causes, it may be due to climatological reasons, it may be due to the nature of the drainage basin, or it may be due to the coastal influences, whereas the anthropogenic causes may be urbanization. Okay, urbanization in floodplain area and deforestation, very rapid deforestation are the major causes. When we see all these causes of floods, heavy rain, the brief torrential rains and the heavy rain followed by the runoff is the main reason for the floods. And other reasons are also there, like tropical cyclones, monsoonal rain, snow melt, dam and dam break, levee break or dam release, and ice jam breakup, and extra tropical cyclones, tidal surge. These are all responsible for in minimum percentage, whereas the heavy rain is the main cause for the major floods. How the majority of floods are linked with the amount of precipitation, it has been explained here. The more rainfall means, or more snow melt, uh, if the infiltration is less, okay, then it causes more runoff. That is, topographic influence on the runoff is the major thing here. Steeper the gradient, faster the runoff. So less gradient, the runoff will become slow. It allows the water to percolate, thereby decreasing the flood, okay, the occurrence of flood. So thus the infiltration depends on the geology of the river basin. Other factors which controls flooding or vegetation. So vegetation may reduce flooding. It provides physical barrier to the surface runoff and decreases velocity of the water and reduces runoff. The plant roots make soils permeable. Good highly planted or with natural forested areas, the permeability of the soil is more due to the plant roots and it increases the percolation capacity. So let us discuss physical causes one by one. Climatological factors. First one is intense rainfall. When the rainfall intensity is more than infiltration capacity, especially in semi-arid areas, it is the main cause for the flooding. And second one is prolonged period of rainfall. It produces the saturation of the soil and overland flow. Prolonged period of rainfall is the cause for all our Karnataka flooding especially, and a sudden increase in temperature producing a rapid snow melt which can be made worse by frozen ground, limiting the infiltration. Nature of the drainage basin is one more cause. So that is infiltration rate depends on the rock and soil of the drainage basin. The shape of the river basin, the gradient and vegetation cover in that drainage basin also affect how quickly the runoff reaches the channel. So coastal influences are like this: high seasonal tides, storm surges, tropical cyclones can result in higher water level in the rivers and low-lying coastal areas. Bangladesh every year experiences this type of flooding. Okay. Human causes for flooding, that is deforestation. So deforestation reduces the interception and evapotranspiration and it increases runoff. Thereby it decreases the channel capacity due to the amount of sediment being carried into the river channel. For example, the Maraca rainforest in Amazon region, that is the photograph of deforestation. So urbanization increased the magnitude of frequency of flood by creation of highly impermeable surfaces. So rapid asphaltation will result in impermeable surfaces, so such as roads, roofs and pavements. Smooth surfaces served by a dense network of drains, gutters and underground sewers effectively increase the drainage density. So natural river channels are often characterized by bridge support or riverside facilities, reducing their carrying capacity. One more thing which is responsible for flooding due to human causes is straightening of river. Okay, straightening of river channels and lining them with concrete as part of building projects will lead to the faster delivery of water downstream, thereby causing the flood. The failure of hard engineering such as dam burst can produce the catastrophic flooding. The nearest example for us is the Kadra Dam and the Koyna Dam are the best examples. And land management techniques such as drainage system, digging ditches or flowing up down slope, and it will decrease the lag time for water to reach the river channel, thereby controlling the flood. These are all the some photographs of effects of flood. Okay. So risk assessment, the process of finding the probability, how likely it is going to happen that a hazardous event of particular size occur within given period of the time and estimating its impact is risk assessment. Impacts of flooding, what are the impacts? Okay, what is we have already discussed what are the causes. Now let us see the impacts. Buildings and property washed away by water and mud, crops ruined and farmland saturated for months, people and animal can drown in a fast flowing river, transport can be interrupted, airport can be closed, roads, railways submerged under water, sewage contamination takes place, contaminate the drinking water supply and causes diseases like cholera, typhoid, etc. There are some benefits also, not only evil effects. So replenishes the groundwater reserves. The flooding results in replenishment of groundwater. Okay, it recharges. It provides nutrient-rich sediment for agricultural fields in dry season, and it reduces the need for artificial fertilizers. The flushes pollutants and pathogens away from the domestic areas. It washes out the pollutants or pathogens from domestic areas. It may increase the fish supply. How to manage the flood? Usually the natural hazards you can't control. You can manage it. You can minimize it. You can't stop it exactly. So during floods, the rivers cause destruction of life, property. Therefore, the flood is important task for civil engineer. Many methods for flood management. The aim of the flood management for a civil engineer is the protection of people and property, reduction of flood risk, monitoring, research, forecasting and warning. Flood management takes place in 3 steps, that is hard engineering techniques, soft engineering techniques and administrative measures. So in this hard engineering techniques, dams, levees, we are constructing some massive civil structures to control the flood, to minimize the effect of the flood. In soft engineering, afforestation, river restoration, wetland restoration, watershed management, flood risk vulnerability analysis, flood zone risk zoning. These are all some of the techniques which has been nowadays we are using for the flood risk management. So third one is administrative measures. Flood warning, rescue evacuation, enforcing the floodplain zoning regulation, flood proofing, etc. So when we talk about hard engineering, the wing dikes are the best methods to control the floods. What does this wing dike is? They control the velocity of the flood, thereby controlling the effect of flood. River interlinking is one of the major hard engineering structures. China, river interlinking method has been used to control the flood and to mitigate the hazardous or disastrous things from the flooding. So in India also central government is thinking of the river linking of Ganga and Kaveri, thereby controlling the floods of North Indian region and as well the meeting the demand of the people. Next is another type of common method to control flood or construction of dams in the upstream hilly terrain and small barriers embankments in the plain region. So construction of dams for controlling the flood is very useful method to limit the amount of water and sediment moving towards the downstream. Dams reduce the risk of flooding by releasing water in controlled amount, that is regulating the flow of main river in a controlled manner. There are so many dams in India for flood control. Example, the Usman Sagar of Hyderabad and Himayat Sagar are the dams for exclusively for the flood control. So flood management once again by improving the drainage also and diverting the flood, you can control the effect of or you can minimize the devastation of the floods. So this is a GCAN project, okay, which has been used in successfully in Japan. So this GCAN's project, an underground water infrastructure is developed in Kasukabe, Saitama, Japan. So it is located between Showa and in Tokyo and Kasukabe in Saitama area on the outskirts of the city Tokyo. So it's the world's largest underground flood control facility or floodwater diversion facility. The goal of this project is to mitigate overflowing of the city's major waterways and rivers during rainy and typhoon season. This is the structure. Here the 5 concrete containment silos will be there, and 6.3 kilometer long tunnels connecting to these silos, okay, and at 50-meter depth from the surface, okay, below the surface. Exactly, this picture shows how the GCANS project works. And when we come to the floodplain zoning, this comes under soft engineering. So throughout India, we have made separate zones for as flood prone, severe flood prone area, minimum flood prone area, like that. Okay, let us see one by one. So the area just aside of the river is zone 3, okay, whereas zone 2 is the area next to the side of a river, and then inland is zone 1. Let's see one by one. So flood hazard zones and management strategies are like this. Flood hazard zone 1, here the active floodplain areas will be there. It prohibits the development of business and residential complexes within floodplains. We have to prohibit here, and maintain area in natural state. We should not intrude the floodplain area. So flood hazard zone 2, alluvial fans and plains with channels more than 1 meter deep. So here the density of construction should be relatively low in such areas, and dry streams should be maintained in a natural state, or density of the natural vegetation should be increased to facilitate the superior water drainage and the infiltration. The construction of the houses should be at higher local level. So it should not be near to the banks of the river. In flood hazard zone 3, it is dissected upland and lowland slopes, drainage channels where both erosional and depositional processes will be here, and it is operative along the gradients of generally more than 5 percentage. So similar to flood hazard zone, this zone 2, this flood hazard zone 3 is, and roadways which traverse channel should be reinforced to withstand the erosion power of the channelized stream flow. In zone 4, steep gradient drainage consisting of incised channels adjacent to the outcrops and mountain fronts are characterized by relatively coarse bed road material. We have to be alert, okay, especially in highly flood prone areas during the seasons, flood seasons. We have to be alert. So flood preparedness, how we have to do, what we have to do, it has been given here. So first one is flood watch. Flooding is possible, okay, and that's what I was telling. It is predictable, so beware of, okay, and watch out. You always be alert. And second one is flood warning. Flooding of homes, business and main roads are expected, so act now. Severe flood warning. In this severe flooding is expected, danger to life and property, so you have to act according to that. And all clear, flood water levels are going down, check it is safe, and return to your original place. Flood management, soft engineering techniques. Flood forecasting is one more technique. So Indian forecasting network we have for flood management. So it covers major and interstate basins. So there are 166 stations for flood forecasting. So for this forecasting consists of 4 steps: data collection, data transmission, data analysis and forecasting, and dissemination. Data analysis and forecast formulation is like that: estimation of total rainfall from hurricane or the typhoon or anything. Estimation of rain is equal to 100 minus the forward speed. Flood intensity is considered to be a discharge along a channel over time. Intensity will be influenced by the rate of runoff, the channel pattern or the shape, the number of tributaries and distance downstream. So in stream order, the smallest tributaries are designated first order, those where first order tributaries join our second order and so on. It will be like this. But the low order streams, the first order, second order streams have very short lag time between rainfall and flood and are more prone to the flooding. Higher order streams with many tributaries are less prone to flooding. So what is the recurrence interval of a flood expected return? Okay, so that's number of peak in the list. Okay, established past records you have to take plus 1 divided by ranked position of the discharge x. This will give the recurrence interval. So how to calculate this recurrence interval? Suppose the records of maximum mean discharge by a particular stream each year have been kept n years. Okay, each of these yearly maximum discharge can be given a rank m, where rank 1 stands for maximum discharge in these years. Recurrence interval can be then calculated as r is equal to n plus 1 divided by m, where n is the number of years, okay, of the records. Usually we take 25 years. In 25 years, the maximum discharge was recorded during any one year, example 1965, so which ranks first in the list. So therefore, if we would like to know the probability of such event, n plus 1 divided m equal to r will be like this: 25 plus 1 divided by 1 equal to 26 years. Or if you want to find the recurrence of similar flood that occurred during 1971 or 1965, whatever the year. So its rank is 7th. Okay, and the recurrence will be for 3.71 years. So the recurrence interval of such frequency similar to 1970 flood is 3.7 years. Flood management scope. What is the scope for flood management? So use remote sensing and GIS, geographic information system, and flood forecast modeling and simulation. Although flood is the most deadliest disaster, still, but it has some benefits also. So recharges the groundwater. Freshwater flood can help in maintaining floodplain ecosystem. It boosts in the food production for birds. So it facilitates the weather. Thank you. Let us meet in next session.